Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, regarding this future engineering, we have discussed a lot. And the previous session, mainly this future engineering on categorical data, we have discussed. So today it is a session on numeric data. So numeric data or fields, variables or futures, typically represents data in the form of scalar informations that denotes on observations or recording or measurements. So of course, numeric data can also be represented as vectors of scalars. So where each specific entity in the vectors is a numerical data point in itself. Integer and floats are the most common and widely used numeric data types. So beside this, numeric data types is perhaps the easiest to process and is often used directly by the machine learning model. Even though numeric data can be directly fed into machine learning models, you would still need to engineer the features that are relevant to the scenario, problem and domain before building a model. Hence, the need for this future engineering remains. The important aspects of numeric features includes this future scale and distribution, and we will just going to discuss some with an examples also in this session. Some scenario we need to apply specific transformation to change the scale of numeric values. In other scenarios, we need to change the distribution of the numerical value, like transforming a skewed distribution to a normal distribution. So let me just discuss one by one. And here we just go, let me just include with the necessary libraries. Okay, so here as usual, pandas, numpy, matplotlib and statistical output we just need. So for that we just included the skypage of stats, and here some advanced parameter for this matplotlib. Okay, so yes, dear friends, we just move on towards this numerical data, mainly on towards how it is measured, raw measures. So just like we mentioned earlier, numeric features can be directly fed into machine learning models, often since they are in the format which can be easily understood or interpreted or operated on. But raw measures typically indicated using this numerical variables directly as features without any form of transformation or engineering. See, typically these features can be indicated in two types, one is as like values and counts. And here values, scalar values in its raw forms indicates a specific measurement, that is metrics or observation belongs to a specific variables or field. So the semantic of this field is usually obtained from the field name itself or a data dictionary if it is present. So let's download a data set. Actually, here we have used a data sets of Pokemon, and of course it is available in the Kaggle. And even though I just share you the GitHub of this code and to the data set in the description, and I just ping it you in the first command also. Okay, so let me just load the data here. So here we just load it and kindly have a view. So here this is what the first. Okay, so we are here to have that. So yes, dear friends, if you observe the data set that is here, it is depicted. So there are several attributes there which represents numerical raw values which can be used directly. Okay, so let me just have some of these features with more emphasis. Okay, so yes, let me just have only specific as like HP, attack and defense of this Pokemon data set. So let I just have age with a head. So this is what. Of course, head, it is just shows only the top 5 records, and you can directly use these attributes as features that are depicted here in this data frame, Pokemon data frames. And here we have included three main attributes, that is HP, that is hit points, attacks and defense stats. And we can also compute some basic statistical measures on these fields, by using the function, that is method describe. So let I just have it. So here we just go. So we can see multiple statistical measurements like count, mean, standard deviation, and quartiles for each numeric features in this output. And let me just try plotting this distribution. Okay, so in coming forth. Okay, so before going on, next we have the exact concepts on counts. See, actually raw data's measures can also indicate counts of frequencies or occurrence of specific attributes. Okay, so let me just have here, see, actually rather than towards Pokemon, so I just want to give you one more data set. I just want to show you this exact sample of data set. It's from a million song data sets, which depicts counts or frequency of that songs that have been heard by various users. Just to have a view, I want to differentiate what is the count and what is the value. So kindly just see here listen count, and you are able to see that is the listen count field, okay, in the this data. So this is how many times or what is the frequency of this, that is the based on towards this numeric feature. And you can also make use, of course we are just going to have this statistical information which is mainly in this numeric data, and kindly just observe, dear friends, numeric data, everything whichever it is just specified here before and in the cell 3 and cell 4. Of course it is an integer and float, okay. And I just want to specify each and every conceptual wise. So let me just discuss it towards the conceptual methodology on towards this numeric data. Next, I just want to give you a small thing on binarization. See, often raw numeric frequency or counts are not necessary in building models, especially with regard to methods applied in building a recommended engine. So for an example, see, if I want to know if a person is interested or has listened into a particular song, I do not need to know the total number of times he or she has listened to the same song. I am more concerned about the various songs so he or she has listened to. So in this case, a binary future is preferred as opposed to count based future. Previously we have just seen the counter. So in such a case we just seen number of counts. Here we are having this particular song ID. Okay, this exact song ID has 68 times. But kindly just see here. Of course, these are the user ID, and this particular person has listened to that one song as 68 times. But this is different between this binarization, okay, and in this case, a binary future is preferred towards this, and kindly just have a execution. I just show you it. So see here, of course watched ones, even though listen count is 68, kindly just see here the watch count. Okay, so yes, dear friends, by using the scikit-learn this binarization class, okay, we can see actually from its pre-processing model to perform the same task instead of by using NumPy. We can also make it into as a methodology. Kindly just I just show you again. Here we have used the NumPy to make it as like a listening functionalities, and we just included this. But here when we just go towards the scikit-learn and using the model binarization, the same listen count that is observed here towards the watched and I show you the difference between. So see here. Okay. So yeah, you can clearly see that, see, actually both the methods have produced the same results, but depicted here with future as like watched and future PD watched. See, actually we have the same, that song listen counts as a binary is the future. So indicating if the song was listened to or not by each user. Okay, not by each user. So here kindly make use of it. Each and everything are in different methodology where which aspect you have to use. Kindly be aware. So of course on practicing only this comes towards in mind. So kindly be on practicing. And next I'm just going to make it on rounding. See, often we dealing with the numeric data. Like proportion or percentage, we may not need a value with a high amount of precision. So hence it makes sense to round off these high precision percentage into a numeric integer. So the integers can then be directly used as a raw numeric value or even as a categorical, that is like discrete class based futures. Okay, so let me just try that by using an data. And here it is of item popularity. Okay, and actually this concept is a dummy data set describing some store items and their popularity percentage. And kindly just have a note here. It is specified as with popularity among 10 and popularity among 100. First of all, I just include load the data. Okay, so here we have the exact data, and kindly just have a note of it. Here we have the columns, the futures as like item ID and pop percentage, that is the popularity percentage, and here we just have it in the percentage manner. Okay, and thus after making it rounding, okay, so here rounding, yeah, you can also make it use of this numpy. I'm just rounding it. You can round it towards 10 or round it towards hundreds, tens or hundreds. So kindly just see here on executing this, we just get, so see here popularity scale among tens and this is hundreds. See, after rounding operation, you can see a new future in this data that is depicting towards the previous. And basically we tried two form of rounding. The future depicts the items now both on the scaling of 1 to 10 and the scaling of 1 to 100. Okay, you can use these values both as numeric or categorical future based on the scenario and based on the objective problems. This can also be done, and how this particular numeric, that is integer format, you are just going to make use of any of the problem statement or any scenario. Yeah, you can also make use of this as like rounded. Okay, now next concept, it is on interaction. Dear friends, a model is usually built in such a way that we try to model the output response as like discrete classes or continuous values as a function of the input future variable. See, for an example, simple linear regression equation, let I just make it y is equal to c1 x1 or c2 x2 till cn x1, where the input futures are depicted by the variables x1, x2 till xn, and having weights and coefficient as c1, c2 till cn respectively. And the goals is the predict response of y. So y is equal to c1 x1, c2 x2, c3 x3 till cn x1. So here in this case, simple linear model depicts the relationship between the output and the input. So purely based on the individual, that is separate input future. So however, see, often in several real world data sets and scenario, it makes sense to also try to capture the interactions between the future variables and as a part of input futures. Okay, so yes, as I have already specified, I just will show you one thing. So without this, see, as I have already specified, so yes, simple depiction of extension of this linear. So here y is equal to c1 x1 plus c2 x2 plus c3 x3 till cn xn. So this is what we just seen. See, in such a case, if this is, yeah, here we have as like x1, x2, x3 till xn, it is the input, that is the variables. And when on towards the weight, it is c1, c2 until cn. So this is simple linear regression. Okay, let me just make a small extension of this above linear regression formation with an interaction. So now we are in the concept of interaction. So let I just make a small interaction. So how it can be, that is y, of course it is the output. Okay, and here I just make c1 x1 and c2 x2. You can just go ahead on, or even you can just make it a cn xn, and still more c11 x1 square, c12 or 22 x2 square, till wherever, see, wherever the futures, it just goes on. So many multiple, you can just include the interactions like here. And here, yes, what would be the input? Previously it was x1, x2, x3 and xn, but here, yeah, you can just go for x1, x2, x3, or here x1 square, x2 square, each and everything. This is what they denote the interaction futures. Okay, so let me just obtain this in this previous, which we have discussed, the Pokemon data set. Okay, so let me just try some interaction futures on our Pokemon. So yes, before that, we just see we have two numeric future, that is attack and defense. Let I just have a view of it. Okay, so this is what, so head, it just shows the top 5 records, and see, by using this is the two numeric futures, and yeah, by building an interaction futures from these two futures, how we are going to make it is, that is attack and defense. Now we want to have an interaction, inclusion of interaction, and kindly just observe here, dear friends. What I'm just including is, yeah, we are going to build a futures. Let me just make it up to second degree, what we have just discussed. Yeah, up to second degree using this polynomial futures. And yes, here I have just included the sklearn pre-processing towards this polynomial futures, and also specified that is degree 2. Okay, so let me just make use of the same thing, and here we apply towards that data only on towards X. Okay, and yes, here let we able to see the degrees of both the numeric future, that is attack degree and defense degree. Let I execute the same. Yes, so yes, of course, as we have already seen, yeah, we know what each futures actually represents from this degree depicted. Okay, so we can assign a name to each future, and then we just move on to further. So here on assigning to it, so 0, 1 and 2. So here what we are just going to do is the attack, defense, attack square, defense square, and product of attack and defense. Here you can just see onto this, we have used fit and transform functionality. I just scroll a little bit, so see here. Okay, so using this fit and transform API functions from this scikit-learn, which is useful to build a future engineering representation object on a training data. Okay, so which can be reused on new data during model prediction by calling on the transform function. Okay, yes, here we have applied, and towards this we just got the exact data, and kindly observe, dear friends. Let me transform this to a simple or sample data. Okay, I just want to give a sample observation, and here we are just going to create a new data frame, and the sample observation, it is like 95, 75, 121, 120, 77 and 60. So this is for attack and defense, and kindly just have a note and let me just have a view. Okay, so this is what attack and defense. Okay, now let me use this exact polynomial function. So see here, we have going to make use of it polynomial future. Okay, so this exact future with the same degree 2, we are going to apply this PF. Okay, I'm just going to include it here and making on towards this transform on new data frame. Okay, so earlier we have created it, and we are going to transform these input future to interaction. So here as towards interaction, kindly just observe the column attack, defense, attack square, attack and defense square. Kindly just observe the new interaction futures value. So here we go. So these are the exact data and we have it. Yeah, so thus you can see that we have successfully obtained the necessary interaction futures for the new data set. Try building interaction futures on 3 or more futures. Okay, this is just an example of having you degree 2 polynomial. Okay, yeah, next moving on towards binning. Dear friends, often when working with numeric data, you might come across futures or attributes which depict raw measures such as values or frequency. So in many cases, often the distributions of these attributes are skewed, in the sense that some set of values will occur a lot and some will be very rare. So beside that, there is also an added problem of varying ranges of these values also. Suppose we are talking about, previously we have just seen songs or videos, the view counts. In some cases, the view counts will be abnormally large and in some cases very small. So directly using these features in modeling might cause issues. So metrics like similarity measures or cluster distance or regression coefficients and more might get adversely affected if you use raw numeric features that having values which ranges across multiple orders of magnitude. So there are various ways to engineer the futures from these raw values. So we can across actually, so we can use this in these issues. So these methods includes transforming, scaling, and quantization. The quantization, it is what's specified as binning. Okay, so yes, we are just going to discuss about the binning, which is known as quantization. So the operation of binning is used for transforming continuous numeric value into a discrete ones. Okay, so this discrete number can be thought of as bins into which the raw values or numbers are binned or grouped into. So each bins represents a specific degree of intents and has a specific range of values which must fall into that bin. Okay, there are various ways of binning data, so which includes fixed width and adaptive binnings is that. Yeah, let me just discuss one by one, and specific techniques can be employed for each binning process also. Okay, now let me just have a particular data called free code camp developer. Okay, this exact coder survey which talks about various attributes pertaining to the coders and software developers. So first of all, let I load it and let's have a peek of its interesting attributes. Okay, so that interesting attributes are, yes, ID, employment field, age, and income. See, actually this exact data set shows some interesting attributes of code survive, and here this ID variable is basically a unique identifier, okay, for each coder or developer who took this survey, and other fields are pretty self-explanatory. Okay, yes, let me just apply this binning one by one, binning methodology one by one. So first we are just going with fixed width binning. Okay, so in fixed width binning, and name of course indicates we have specific fixed width for each of the bins, so which are usually predefined by the user analyzing the data. and each bin has a prefixed values which should be assigned to the bins on the basis of some business or custom logic, rules, or necessary transformation. And here, dear friends, actually this binning based on this rounding is one of the way where you can use the rounding operations that we discussed already previously. So that also you can just use to bin raw values. And okay, let me just consider one among the future here, which we just had it, this age. Okay, so here this age futures from this coder, let me just use it, and we just develop a distribution of this. Okay, so to develop a distribution, so let me just have an histogram, and let me just observe. Okay, kindly just observe, this is what. So here this exact distribution of developer age, which is slightly right skewed, of course, is right skewed as expected, of course. Okay, so let assign the raw age values into specific bins based on some logic functionality, and here I am just going to give you the logic as like this. So on rounding, so if it is the age 0 to 9, I am just going to specify the bin as 0, 10 to 19 as 1, 20 to 29 it is 2, 30 to 39, 40 to 49, 50 to 59, and 60 to 69, and so on. So yes, dear friend, here we can easily do this using what we have already done in rounding section earlier. So where we round off these raw age values by taking the floor value after dividing it by 10. That is also, you can just make it. And yes, that exact floor value, kindly observe, this is what age bin round. Let I execute it. So observe the exact output. And yes, dear friend, here we just specifically slice the data set, the rows from 10712 to 1076, okay, to just depict users of varying ages, okay. And you can just see the corresponding bins of each age has been assigned basing on rounding. So 17, it is 1. Kindly just see, I just scroll a little bit. So here it is, yeah. So yes, if it is 10 to 19, the bin is 1. So that is what here it is specified. So as it is 17, the age round is 1, and for 38 it is 3. Yes, of course, observe 38 it is 3. Okay, so but if we need more flexibility, what if I want to decide and fix the bin with widths myself? Yes, binning based on custom range is the answer to all our questions. So about fixed width binning, yes, some of which I just specified. Okay, so some custom ranges of binning developers, we can also make use of it as like, yes, I just scroll down. So kindly just see here, this is also, it is possible. So 0 to 15, it is 1. 16 to 30, it is 2. 31 to 45. 46 to 60. So these are all exact custom ranges, and yeah, we will now label the bins for each of this developer age value with the help of this code. Kindly just observe. So this exact ranges 0, 15, 13, 45, 60, 75 and 100 we are customizing here. Okay, and corresponding the labels, and kindly just observe what it has towards the output. So here we have, so 15 to 30, 30 to 45, and it can be also falls in 15, 30. See, actually we can see this from this data frame, the custom bins based on our scheme have been assigned for each developer. And yeah, of course, dear friends, as I have already specified, try out some of your own binning schemes. Okay, own binning schemes, and yes, each and every thing whichever we used to discuss, kindly just practice it with different datas and different methods and concepts. Okay. Yeah, next we are just going for quantile based binning. Dear friend, of course, we have decided the bin width, the range in fixed bin width, but however, this exact technique can be leading irregular bins that are not uniform based on a number of data points or values which fall in each bin. Some of the bins might be densely populated and some of them might be sparsely populated or even something maybe empty. And here adaptive binning is a safer and better approach where we use the data distribution itself to decide what should be appropriate bins. And yes, dear friends, quantile based binning is a good strategy to use for adaptive binning. And quantiles are specific values or cut points which helps in partitioning the continuous value distribution of a specific numeric field into discrete continuous bins or intervals. And here, yes, the quantiles Q helps in partitioning a number attributes into Q equal partition. So, popular example, as we have just specified, popular example of quantiles here includes two quantiles known as the median, which divides the data distribution into two equal bins. Of course, we have already discussed that. And if you just go for four quantiles, which is known as quartiles, okay, yes, that is also which divides the data into four equal bins. 10 quantiles also known as deciles, which creates 10 equals bins. So many things are there. Yes, dear friends, let me just discuss, and we have some informations. Okay, so here, yeah. Here we are just going to have the same data pertaining with slicing from 4 to 9. Okay, and let we have 8. So here we just go. Okay, so this is what the exact data, and this data just shows the income values for each developer in this data set. And let me just have a look a distribution of this. Okay, so of this income variable. So by using this income variable, let me just have a distribution. Okay. See, we can see from this distribution that expected there is a right skew with lesser developer earnings and more the money. Okay, more money and vice versa. Of course, let's take a 4 quantile, that is a quartile based adaptive binning scheme. Okay, so insides of quartile based, yeah, it just 0, 2.5, 0.5, 7.5, sorry, 0.75 and 1. Okay, so this is what where the exact income values that falls on 4 quartile distribution. Okay, so let I just execute it and kindly just see. Okay, so I just go above and show you the income here. Okay, so 6,000, 4,000, 32, 40 and 80. Okay, and here as it's 6,000, it shows the exact quartile where it is. And yes, dear friends, this is the quartiles that is obtained here. And yes, let me just plot it. Okay, let me just plot it, and let me just see about this data distribution first of all. So yeah, same thing, let make on using this same histogram and kindly just observe it. Yes, here we go. So yes, dear friends, here the 4 quartiles, kindly just values of income are here depicted in this red line, red vertical lines. And let's now use this exact binning to bin each of the developer income into a specific bins also. We can also make use of it. And for that specific income, okay, so the same 4 to 9 we are just going to use it. So let me just have it and view it. Okay, so here it just shows this is what. So yes, the age, sorry, this is ID, the age of the developer, and income quartile range, and income quantile label. And here it just shows that quantile based bin range and corresponding labels assigned for each developer income value. Here the futures are specified respectively. And next, I just want to specify one thing related towards this statistical transformation. Yes, of course, which we just say mathematical. See, different strategy of future engineering on numeric data by using statistical or mathematical transformation. Okay, so let me just have a look onto this log transformation as well as box cost transformation. That is the two. Okay, see, both of these transform functions belongs to the power transform family of a function. These functions are typically used to create monadic data transformation, but their main significance is that they help in stabilizing variance, adhering closely to the normal distribution and making the data independent of the mean based on its distribution. So several transformations are also used as a part of future scaling. Okay, now here we just use only this two transformation. One is log and box cost. When coming towards this log transformation, kindly just observe one thing, dear friends. Log transformation belongs to power transform family of function, and this function can be defined as like y is equal to log of x. So I just showed you. Okay, so here of course we just specified y is equal to log b of x, and here which reads as log of x to the base b, which is equal to y. And this translates to b to the power of y, which is equal to x, which indicates us that as to power must be the base b be raised to in order to get this x. The natural logarithmic uses the base b, which is equal to e, and here where e it is 2.71828. So actually there is known as this Euler's number. Okay, this is Euler's number, and you can also use base is equal to 10, which is used popularity in the decimal system. And logarithmic transformation are useful when applied to skewed distribution, as they tend to expand the values which fall in the range of lower magnitudes and tends to compare or reduce the values which fall in the range of higher magnitude. Okay, so this tends to make the skewed distribution as normal like as possible. Okay, so let us use this log transformation in our developer income futures, and let me just have our coder survived data system. So here we just go, let I just apply here. Yes, here we obtained the output, that is log transformed. Okay, so log transformed future. So the income future in log transform, and yeah, first of all, be making it towards this number. Let me just have the plot and the data distribution of this transformed future. Okay, so then only we can just observe the difference. So here we have, so how come? Kindly just observe. It is can clearly see that the original developer income distribution that was rightly skewed previously. I just to show you, this is what rightly skewed. Now how come it is? Yeah, it's more Gaussian or normal like na. So yes, after applying logarithmic transformation. Okay, let I just go with box cost. Yes, of course, box cost transformation, another popular function belonging to the power transformation family. Okay, so this function has a prerequisite that the numeric value to be transformed must be positive. That is similar to what log transformation expects. Okay, so in case they are negative, shifting using this constant value helps That is mathematically, I just show you this is the exact box cause. Okay, I just specify this is the exact box cause. So y is equal to, that is f of x lambda, which is x lambda, and towards, I just let you know the equation for the lambda that is greater than 0, and log e of x for the lambda that is equal to 0. So yes, of course dear friends, I just explained this. So this resulted transformed output y is in the function of input. Okay, so input x and transformation parameter, this is lambda. Okay, and such that when lambda is 0, the resultant transformation of natural log transformation, which we just already specified. Okay, so the optimal value of this lambda usually determined using maximum likelihood or log likelihood estimation. So when on just applying on towards this box cause, so kindly just observe. So let me just apply this towards our income. Already we have just having that income data futures. Okay, developers income futures. So let me just apply here. So here we are having our box cause, and of course I have already included this statistical functionality, and let we have. Okay, so yes, we have obtained the optimal lambda value. So here the box cause transformation of two values, that is lambda such that lambda which is equal to 0 or lambda that is equal to lambda optimal. Okay, so that is what we just seen. So let me just transform the raw numeric value that is pertained towards developer income, and here what we just got the exact value here, it is 0.11799. okay, so we are just going to have such that it is lambda, it is 0 and lambda that is equal to lambda towards the optimal value. Okay, so let we make on towards that on to the data. So here lambda to 0 and lambda to optimal. And here also we are just going to make pre-trained developers incomes for 4:9. Okay, so here this is what, so it just shows the income futures after applying this box cause transformation for lambda 0. Okay, so this is lambda 0 and lambda towards lambda optimal. Okay, in the income of box cause lambda function. Okay, have the same functionality. Kindly just observe here dear friends, this is income log and income lambda 0. We just have the same values as the box cause with lambda is equal to 0. But now when on plotting it towards this distribution, kindly just observe the transformation of this lambda optimal value. Kindly I just want to see that lambda optimal value which has a deviation now, so which has a difference. So wow, so distribution of this transformed numeric values of this developer after this box cause distribution or looks similar. Yes, exactly, it looks similar to the one we have obtained after this log transformation. Yes, you can also have this, kindly just observe. So above here, this is log transformation, and here we just get it in our box cause. Okay, so yes dear friends, so looks similar to that one we had obtained already. Okay, so such that it is more like normal like and that not also which we have already seen as like extreme right skew. Now it is normalized, and yeah, what is the raw data that has been minimized here? Okay, yes dear friends, so we are coming to the end of this, and with the completion of this future engineering session, we have explored the critical techniques of transforming both numeric and categorical data, and from scaling and normalization numeric for futures to encoding and handling categorical data. Each process is essential for enhancing model performance. So by refining these skills, you ensure that your data is well prepared, laying a strong foundation for building precise and reliable machine learning models. Okay, so yeah, we are still there in two more topic as future scaling and future selection. Yes, kindly just subscribe this channel so that you can just don't miss that important concept. Okay, so yes, dear friends, kindly just practice with similar different data or similar data type functionalities, and see you in another video, and thank you and happy learning, dear friends.